Lab Guy here. I have a short update about the NBTV vivisector tube camera. I don't recall if I've shown it at this point, but the main body of the unit is fully assembled. I glued these two parts together. I glued in the deflection yoke. I brought out the wires. I designed on the feet for this to sit on. It will be sitting on top of an aluminum project box. And the final piece, what I call segment C, I had to print 3 times to get it right. Each time improving the dimensional stability. If you'll note, let me get a better grip on this. I don't want to drop it. There are 3 screw holes in the front here, which I printed at just the right size that a number 632 American Standard Thread screw will screw in and self-tap. I then printed segment C, which is our lens holder, and I had to print it 3 times because I got every single dimension wrong. The front recesses for the screw heads were too small, the holes that go through were too small, and this bugger here was 2 millimeters too small. I got that one completely wrong. So at any rate, I've got the dimensions corrected now. This goes on here and is held on by 3 screws. You can see the face of the tube in there. Now, to mount the lens on here, I have a lens mount that I salvaged from an old broken camera. I don't remember what brand. I believe it was a Panasonic camera. I'm not sure. It might have been the Concord variant of it. And it's got the C-mount 16 millimeter threaded hole for the lens to mount to, and on the back it's threaded here. I don't know what the pitch is, but I did get the dimensions of this and transferred that to this unit and made this hole just a hair smaller than the outside diameter of those threads. And on the 3rd try I got the size right. Now initially this did not thread in. I had to thread that hole. So I used the lens mount itself to do the threading by coating it with this 3D printer grease that I got, which is a lithium grease. It's food grade. And driving this in and taking it out 3 times. And now it screws in fairly easy up to a point. And to put it in, if you'll note the 2 indentations for a special wrench, which of course I don't have, it can be driven the rest of the way. So let me show you my solution to that problem. What I did was to take a large pair of needle nose pliers and open them to the exact dimension to fit those 2 indentations in this lens holder, and then clamped it solidly in my bench vise so that these jaws don't move. They hold their the width just right, and then I just rotate this thus until the lens mount is fully seated. And just like that, the lens mount is in. It's flush to the surface. It's luckily I got it square. It's not off at an angle. And we now have a perfectly centered 16 millimeter C-mount lens holder to take a 16 millimeter C-mount lens, which coincidentally has a focal length of 16 millimeters. The lens holder goes onto the front of the unit like so, and is held on with 1-inch Phillips head number 6, 32 threads to the inch, 1 inch long screws, 3 of them. Completing the assembly. And like that, we are ready to move on to electronic design and construction. Now, I have made this tube make pictures in the past by taping a slide to the front of it and shining a pretty bright light onto it. A very bright light, I should say. Not that the light was pretty, but it was bright enough to do the job for sure. And we were able to see the image on an oscilloscope. This camera will be designed to operate in the 32 line NBTV mode. It has the pre-made tube circuitry on the back, which I obtained on eBay. I have now got 3 of these units and 3 different tubes, all of different specifications, and I cherry-picked this particular FW130 image dissector tube because it is clearly marked what its aperture size is, which is 40 mils, and if my math is correct, it is absolutely perfect for a 32 line picture. Here's a better look at the entire assembly. You can see again the support electronics in the base, the primary body made of 2 pieces, and the front lens mount. I call these segment A, segment B, and segment C. And I printed some flat supports on the bottom for this to sit flat and not roll away. And it will, as I've said several times, be mounted to a aluminum box. The other detail that I ran into is on the back here. The 2 connectors on this unit, one of them is a standard BNC connector. This is the cathode end of the tube where the signal will come out, and this is the anode end of the tube where the high voltage goes in, and it runs on 1000 volts. This connector is what's called a TNC connector. So I was able to buy a small cable that has a TNC connector on one end and a BNC on the other. I will be cutting off the BNC, and it fits perfectly. So that completes the requirements to get connections to this unit. It will be very clean. The deflection yoke wires come out of the bottom like that, and will pass through a hole in the top of the main box down to the deflection circuitry. So that is the mechanical construction of the NBTV DissectorCam project, and hopefully soon we'll have enough electronics going that we can give this thing a test. Welcome to all the new subscribers as usual. Greetings to all of my current subscribers. The channel wouldn't be fun without you guys watching. Thank you for your viewership. I appreciate the heck out of it. I really do. You guys are all right. So until next time, this is Lab Guy, out.